All right. Let's see. If you guys would please find your textbooks. We're going to be in chapter 12.1, and we're going to start on page 714. Yeah, we're going to start on page 714. Let's see if we can get it. There we go. All right. So we're looking at bar graphs today. Some graphs are used to display data that consist of different categories. Bar graphs display data using horizontal or vertical bars so that the height or length of the bars indicates its value for a specific category. Okay. The bar graph shows the number of granola to-go variety packs sold in the first 6 months of the year. The bars are vertical. Okay, so I have sales of granola to-go variety packs from January, February, March, April, May, and June. Okay, and my bars are represented vertically, as in the number of variety packs sold. So for January, we can see that the number of variety packs sold would be 8, and it tells me it's times 10,000. So there was 8,000 boxes sold in January. Okay, all right. What does each bar represent? Well, each bar represents the number of granola packs sold by month. So each bar represents the number of packs sold each month. Okay. So which month has the most sales of granola to-go variety packs and how many were sold? Okay, well, now I just have to look for which bar is the highest, and it seems that May is the highest. And I'm going to follow that line all the way over to 10, and notice that it's still times 10,000. So I sold 10,000 bars. Or no, not 10,000. Hang on. May, and we're going to take 10 and then multiply 10,000 to it. Okay, I was just off by 1. Now remember my ones trick, I multiply the whole numbers of 1. And then I add the number of zeros that I see, and I see 5 zeros. So 1, 2, 1, 2, 3. And in May, I sold 100,000 packs. Okay. Letter C, how many granola to-go variety packs were sold in the first half of the year, January through June, according to the data in the bar graph? Okay. All right, so January, we're at 8. February, I'm at 9. March, I'm at 4. April, I'm at 7, because notice I'm between 6 and 8. Well, in between 6 and 8 is 7. May, I'm at 10. And then June, I'm at 8. Okay, so what I need to do is take all of these numbers, multiply them by 10,000, and I'm going to add them up together. Okay, let's see here. I think there's an easier way to do this. So 8 plus 9 plus 4 plus 7 plus 10 plus 8. So let's take this. Let me make it easier for you guys to see. All right, 8 plus 9 is what? 17. 17 plus 4, 21. 21 plus 7, 28. 28 plus 10, 38. 38 plus 8, 46. Okay, all I did was add up all of these numbers right here. And now I'm going to do 46 times 10,000. Remember my 10 trick, multiply by the whole numbers and then add the amount of zeros that you see, which is 4. And you will have sold 460,000 packages of granola bar. All right. Number 2. The graph titled Average Lifespan of Animals is an example of a bar graph where the bars are horizontal. So this time we're going this way. Okay. Which animal has the shortest lifespan according to the graph? Well, I need to find the one that has the shortest bar, and it looks like dolphin is my shortest bar. So dolphin has the shortest lifespan. Okay. Which animal has, on average, the longest lifespan according to the graph? Well, now I need to find the bar that is the longest, and according to my graph, donkey has the longest lifespan. Okay, letter C. How long does the average donkey live? How did you calculate your answer from the graph? So we're going to look at the graph, and I'm going to find the donkey, and it looks like the donkey is just a little over this line right here. Well, this line is 45. Well, notice that my scaling is going up by fives each time I write a line. So I'm between 45 and 50. Well, I'm really close to 45. So I'm going to say on average, about 46 years. Okay. On average, 46 years. Okay. Because it's not halfway between 45 and 50. It's really close to 45. So I'm going to assume that it's 1 year over 45 to be at 46. Okay. Letter D, what interval is used to record the number of years on the bar graph? Well, it's asking me, what am I going up each time? What are my intervals? And we just found that it's going up by 5 years or 5-year intervals. Okay. Why do you think the bar graph includes average in its title? Explain your reasoning. Okay. So if you think about it, can we go around and look at every single, let's say, dolphin? Okay. Can we go around and record every single dolphin and figure out when it dies to see how long it's going to live? No, it's physically impossible. Okay. So we cannot record every lifespan of every animal. So we calculate an average of how long they live. Okay. All right. What other name could you use to replace the word average in the title? Okay. So usually when you think about it, so let's say, for example, we did a study at a zoo and we watched, the number of, let's say, elephants. We watched the number of elephants come in. We record how long they lived, and so on and so forth. And say we got 5 elephants and we recorded how long they lived until they died. And then once they died, we recorded their years. Okay. And then what we did is we calculated up an average. What else could we say average means? Well, average could mean mean. So average could be substituted for the word mean. Because usually when I'm asking you guys to find me the mean of a data set, you guys are finding the average of a data set. Okay. All right. Number 3. All right. So I'm going to compare the average lifespan of animals bar graph with the sales of granola to go variety pack bar graph. Okay. So I'm looking at my 2 graphs. Looking at this graph and I'm looking at this graph and comparing them. So Melissa says that the graphs are similar because in both graphs, the frequency of the data in each interval is represented by the height or length of the bar. Ophelia says that the graphs are similar because in both graphs, the intervals are the same. Who is correct? Okay, well, let's look at it. So my interval here, so for my bar graph here, okay, is going up by 2. So 2, 4, 6, 8, 10, 12. My intervals here are going up by 5. So 5, 10, 15, 20. Are my intervals correct? No, they're not the same on both. Okay. So I know Ophelia is not correct, but let's see Melissa. Melissa says they're similar in both graphs because the frequency in the data and each interval is represented by the height or the length. So how often, so frequency means how often something happens is represented by the height or the length of my data. Is this correct? Yes. So the person who is correct is Melissa. My data, spelled frequency wrong. Frequency, okay? My data frequency, or in other words, how often, is represented by height or length, Length, okay? Ophelia is wrong because, what was it, granola has interval of 2s, and then animals interval of 5s. Okay. All right, letter B. In what other ways are the bar graphs similar? Name at least 2 similarities in your answer. Okay. All right. So let's see here. We're going to look at our 2 bar graphs here. Okay. Well, the first thing that I noticed that both bar graphs have that are very similar. Now, they're not the exact same. They're not like the same, but as far as intervals, all of my intervals are equal between each of my bar graphs. They're not equal between like the same as both, but this one right here is going up by 2s each time, and this one right here is going up by 5s each time. So my intervals are going up in an equal manner. Okay. And let's see another one. Let's see here. What else do you guys notice? Well, the other thing I notice is that the width of each of my bars on this one are equal. And the width, so this one would be the height, whatever, of each of my bars is equal. Not one bar is bigger than the other, which that does make a big difference. Okay. So what I'm going to say is all bars within each graph have the same width. Okay. All right. And letter C, how are the bar graphs different? Name at least 2 differences in your answer. Well, the first one we can label is one is horizontal. Okay. Side to side. One is vertical. Up and down. Okay. And the other one is telling us, so on our granola, okay, it is telling us the number of sales that took place. Okay, so this one is telling us the number of sales that took place. And this one is telling us the mean average of lifespans in animals. So granola, number of sales, and then animals, mean of lifespan. Okay. All right. If you would, we are now skipping the rest of problem 1, and we're going to flip our page over to 718. And we're going to look at another bar graph. Now, this one's a little different, so let's look at this one. So Jim owns a fruit stand at a local farmer's market that he only opens on Saturdays and Sundays. Jim recorded the amount of fruit he sold last weekend. Okay, so Jim displays his data in a double bar graph, which is represented when each category contains 2 different groups of data. The bars may be vertical or horizontal. A key explains the colors and patterns for each group. The two bars representing the same category are side by side. Space is used to separate the categories. So apples are here, peaches, oranges, and bananas. Oh, sorry. And if I look at my key here, the lighter color is Saturday, the darker shaded is Sunday. Okay. And so each category, so between each for the fruits, I have space in between. And it looks like the amount that I sold is on the left, which is going to represent how high my bar is. So my bar height for each day, so for Saturday and Sunday, represents how many kilograms of each of that fruit that I sold. Okay. All right, so use the double bar graph to answer the following questions. What does the key tell you? Well, the key tells me what the different shaded bars represent. Okay, it tells me what each of the different shaded bars represent. Okay, that the light equals Saturday and the dark equals Sunday. Okay. All right. How many kilograms of apples were sold on Sunday? Okay. So I need to go to apples. Well, I look at my key and I see that Sunday is the darker. So I'm going to look at the darkest bar for apples, find where it touches the line, and it hits it right at 50. So there were 50 kilograms sold on Sunday. Okay. Letter C, which fruit showed the greatest difference in sales over the 2 days? Okay. Well, I need to see which one, okay, would have the biggest difference. So let me zoom in here really quickly. Well, it looks like I'm going up by tens, but in between each 10, there's a section or there's a line that's going to represent halfway. Well, apples, I sell 50 on Sunday and 45 on Saturday. Okay, so that's a 5% or 5 difference. Okay, let's look at peaches. On Saturday, I sell 30, but on Sunday, I sell 20. Well, that's 10. Okay, so right now, peaches is in the win for selling the biggest difference. Well, oranges sell 20 on Saturday and they sell 15 on Sunday. So 20 to 15, that's a 5 difference. Right now, it's still peaches. And then look, bananas sold the same, so there's no difference. So the fruit that sold with the biggest difference is peaches. Okay, peaches showed the greatest difference. And then what was the difference between Saturday sale and Sunday sales of your answer for part C? Okay, well, we saw that Saturday sold, what was it? 30. Saturday sold 30 kilos. Sunday sold, let's see where to go, 20. Saturday sold 30, Sunday sold kilo for a 10 kilogram difference. For a 10 kilogram difference. All right. Here we go. Okay. Which fruit sold the smallest difference in sales over the 2 days? So if I go back to look at my bar graph, I want to know which one sold the smallest difference between the 2 days. I can easily see that. And that looks to be the bananas, because did the bananas have any difference between Saturday and Sunday? No. So that means there was no difference between the two. So the one that sold the least was bananas, Bananas. Okay. And what was the difference between Saturday sales and Sunday sales? Well, there is no difference. Or there was no difference. Sold the same. There was no difference. They sold the same. Okay. Let's look at one more different bar graph. Okay, let's look at one more, and we're going to be on page 722. 722. All right. Boys and girls in an after-school program were asked which sport they preferred. Their answers are recorded in the graph shown. Okay. The sports preference of girls and boys displays in a stacked bar graph. Okay, that's this bar graph here. A stacked bar graph is a graph that stacks the frequencies of two different groups for a given category on top of one another so that you can compare the parts to the whole. Each bar represents a total of the whole category, but still shows how many data pieces make up each group within the category or the entire category. Okay, so use the stacked bar graph to answer the following questions. What does the key indicate? Well, the key tells me that light equals girls, dark equals boys. Okay. All right. How many total students prefer basketball over the other choices? All right. So let's see here. Let's see how many people. So if I look at basketball, I'm going to look over at basketball. I'm going to see the height of basketball, and it tells me that 30 students prefer basketball. Okay. How many girls and how many boys prefer basketball? Okay. Well, let's see here. I'm told that girls is the gray and boys is the dark. So if I look at girls, I go from 20 to 30. Okay, well, that's 10. And then from boys, I go from 0 all the way up to 20, which 20 plus 10 should equal 30. So 10 girls. I can spell girls, right? Girls. And then 20 boys. Okay. And letter D, which sport is preferred equally by the boys and the girls in the after-school program? And how can you tell? All right, so let's take a look here. All right, so soccer, it looks like 15 boys prefer soccer, 15 to 25, while 10 girls prefer that. That's not equal. We see that basketball is not equal. Okay, so let's look at track. Well, 0 to 10 boys like track. Well, 10 to 30 girls, so that's 20 girls prefer track. That's not equal. Let's look at volleyball. So 0 to 15 kids like volleyball. And then 15 to 30, that's another 15 girls that like volleyball. So the volleyball shows an equal representation between both the boys and the girls. There's two ways you can tell. The first way, one, you can do the math by seeing, how high each bar is represented. Or two, you can look to see where is it cut directly in half. Okay. So which sport is preferred equally by both girls and boys? And that is volleyball. With 15 per students. Okay. And you can tell because the bar is split equally in half. Okay, because the bar is split equally in half. If you guys have any questions on this, please let us know.